Okay, so I'm going to try to go over in about 10 minutes time. Page 115, rigid motions number 5. This is called dilations. Everybody say dilations. Do you know this word? Like if you hear the word dilation, what comes to your mind? Dilate, good. Good. But what does that, go one more step. What does dilate mean to you?
It's like when your eyelid changes?
She went like this with her eye, like your eye, your pupil or whatever, changes, right? Your eye dilates. It changes. What's another way? What words do you use to describe this? Enlarge. Dilute probably comes from the same root word, but in this case, we're thinking of get bigger or get smaller. You with me? Yeah, I think dilute is absolutely acceptable in terms of it's coming from that same root word. Okay, so dilation in geometry is get bigger or get smaller. Fair enough? Okay, are you doing the school G's for rigid motions? Do you find them kind of simple? I'm hoping you do. I'm hoping you go, this isn't so bad at all. So dilations technically is not a rigid motion. Rigid motion is where you take a shape and you move it, like you translate it from one place to the other, right? Over here is a translation. You take a shape and just move it or slide it. That's why it's a rigid motion, because the shape's not changing itself. So technically speaking, this is not a rigid motion, but I put it into this unit just because it's easier to cover right now. You okay with this? So if your other teacher goes, it's dilations is not a rigid motion, they're right. I just put it into this unit because it's easier to go over right now. Okay, so here's the question. How can we expand or shrink a shape so that we can predict its new coordinate locations? Do you remember coordinates? Okay, I got some. I'm trying to get you to go yes. Right? Coordinates come on a Cartesian coordinate plane. You have two axes. What's this axis called in this direction? Good. Everybody say X.
X.
Good. And then this one, the vertical is Y. When I was a student, I thought that they could change that on me. They never ever do. It's always the same. This is always X. This is always Y. That's 2 dimensions. What's the third dimension called?
Z.
Z. Good. And in this is one of the few times in math maybe where it makes sense. X, Y, Z. What's the third? Like if you're looking at this and it's flat, and this is 2 dimensions, X and Y. What's the third dimension?
Z.
It's Z, but where is it? Where is it? Use your hand or arm or something to tell me where Z is. Yeah. Andrew went like this, right? I think he went like this. It's the distance. So it comes out from the board at you. That's the third dimension. You okay with this? Okay, so we're in 2 dimensions. We've got X and Y. We've got a shape. In this case, it's a rectangle, right? So see all these? This says rectangle ABC. This says rectangle ABCD. I got to give you the 4th one because there's 4 points that make up the rectangle, right? So when you look at this rectangle, ABCD. Fair enough? You okay with this? Pretty simple. You're going to go to a dilation of this or a dilation of this. Dilation can also be shrinking, although we think of it as always getting enlarged, right? We think of dilation as getting larger. A dilation can be shrinking also. It's like a positive and a negative. Positive being an enlargement, a negative being a shrinkage. Is this okay? Okay. If we go from A to this A tick mark, what do you call the tick mark? Yeah, everybody say prime.
Prime.
So you have A and A prime. Say A prime.
A prime.
Does this make sense? It's the same. It's still A, but now it's a new one. And so you just tag prime on it. You could have a double prime, a triple prime, etc. But it all links back to the original A. This one, before it's adjusted, again can be called or thought of as the preimage, right? This one could be called the image, and that's taken from rigid motions, although sometimes dilations don't necessarily use that language. I think it's easier for your brain to kind of think there's something before, there's something a starting point, and then it adjusts to something new. Okay. These are coordinate locations, which always go X, comma, Y for review. So if this is negative 7, 3, it goes back 1, 2, 3, 4, 5, 6, 7. I didn't even put in the tick marks. It goes back 7 and up 3 to be this point right here. Okay? This is back 4, up 3. This is back 7, down 3. So you've got negative because it's below the x-axis. And I didn't label x or y, but this would be x and y. Right? Okay, so here's the instruction. Draw a dilation of rectangle ABCD under the center of dilation with scale factor of 2. In this case, they're telling us the center of dilation is 0, 0. What's another name for 0, 0?
Origin.
Yeah, everybody say origin.
Origin.
When you say the word origin, what else do you think of? The beginning. What else? What else you say? Origin is beginning or starting point or anything like that. Think of like the creation of the earth or whatever. Creation was the starting point. So is the origin, right? The origination, all that. Does this make sense? Okay. From here, we're dilating and we're going to go a scale factor of 2. Say scale factor.
Scale.
Another name for scale factor is zoom factor. Say zoom factor.
Zoom factor.
On your phone, you know when you zoom in or out on something? Now it's very relevant to you, even in terms of how you're pinching it and going this much. If you're looking at a photograph and you enlarge it, can you go to a scale factor of 2? What would happen to the original image? How much bigger would the second image be than the one you started with?
2 times something?
2 times it. You okay with this? I mean, yeah, in this case, it's exactly what your brain is thinking. Trust yourself on this one. Scale factor of 2 would be to enlarge the picture by 100% or go 2 times as big as it was. You okay with this? Okay, reverse it in your mind. Say you started with a picture on your phone and you wanted to shrink it by half. Now you're shrinking down, and so the second image is half the size of the original. You okay with the idea of enlarge or shrink, right? I think pretty obvious to you, right? In terms of even if you're using your phone and that kind of stuff you use every day. When you're using coordinate locations, which the Schoology will give you problems on, you're simply, if you're using a scale factor of 2, these are all getting multiplied by 2. Because we're using the origin as the basis of dilation. All right, so, and another word for basis of dilation is center of dilation. Say that. Say center of dilation.
Center of dilation.
Everybody say center of dilation.
Center of dilation.
Everybody say center of dilation.
Center of dilation.
Go, Leo. Say it.
Center of
Thank you, guys. Thank you. Thank you. I feel like Leo's like, I'm not going to say it. But thank you. I appreciate that very much. Okay, you guys. So here's the enlarged, right? See how it's minus 14 now? We started with minus 7, minus 14. Multiply by 2. 3 went to 6. Minus 4 went to minus 8. 3 went to 6. This is your most basic dilation, right? That's the one you're starting with. They can get a lot more complicated than this, but in general, you're not working with too difficult shapes. You're working with either rectangles or triangles and those kind of things. Think about scale factor for a second and what we said. If you started with an image and the image got larger by 2, the scale factor was 2 because it got larger. You multiply by 2. However, if you started with an image and it went down by a factor of 2, now you're going 1/2. So notice that the scale factor is set based on the direction of the change of shape. Is this okay? So someone could say a scale factor of 2, that would mean you were enlarging the shape. If it's a scale factor of 1/2, you're literally putting 1 over the 2, and now you're getting the 1/2. Pretty logical. However, you just have to think, if somebody says, what's the scale factor? Your first question in your brain is it getting larger? Because that'll be a number above 1. Or is it getting smaller? That'll be a number below 1. So, scale factor flows in one direction or another, and just back here on the idea of a scale factor of 1. If something is changed by a scale factor of 1, this is kind of a trick question, how much is it changed?
By 1. 0.
None, right? I think that's what you mean when you say by 0. If a shape is multiplied by a scale factor of 1, it doesn't change size. Fair enough? 1 is the middle. It's okay, Santiago? Does this make sense? If you take a shape and you change the size, dilate it by a scale factor of 1, it doesn't get larger, it doesn't get smaller. It has to be 1.1 or something like that to get a little bigger, or it has to be less than 1, 0.9 or 1/2 to go down in size. That's okay? So your medium or no change scale factor is 1. Above it makes it larger. Below 1, like 1/2, which is below 1, it's 0.5, right? Makes it smaller. Is this okay?
Yeah.
Just like I know this, it's just review. Sorry. Yeah. Sorry. You okay with this? All right. In Schoology, there's a bunch of them and triangles that you're going to practice, and pay attention to the to the coordinate locations, because this is where it gets a little bit more complicated, right? Besides just the basic idea of enlarging or shrinking. All right, I think that's it. Hit stop. Is this okay?